So this is my demonstration of my individual project. So this individual project is based on the Spark Master framework, and you can see there is a Spark Master, and we have two worker and the application running on this. So talk about my individual project. So in my individual project, I'll use two kind of datasets, and each dataset has several tables, and one dataset for two assignments. The first part is for the classification and clustering, and the second part is for the regression and association rule mining. So let's begin my demonstration. So first, you can see this is my name of my individual project, which is individual project, and you can see the train dataset and test dataset. I just import them from the HDFS file system. So basically, I do not need to manually split my train dataset and test dataset, because in my original dataset it has the train dataset and test dataset. So the first part is the data visualization. So I use the pandas data frame to do the data visualization. Actually, the dataset is about the real position and the speed, and the simulated position and speed of the satellites. Okay, many kinds of satellites. So you can see this is kind of features relationship between each other. So you can see this is the data visualization, and this is also another kind of data visualization. So actually, I specifically select three kind of different speed satellites. So you can see this is like the movements of the satellites. This is the time position. This is the time and the speed. So next, I just want to show the description of this dataset. So you can see this on the output, and check the missing values and check the outliers. Use the box plots, and also I want to check the outliers from the feature map of each kind of correlation of each features. So because if you have the outliers, you can see that obviously. So you can see all these features look good. So the first task is the regression task. So the first one is I use the linear regression to do the task. I use the PySpark machine learning lib and regression and evaluation to do this task. And also I import the dataset and choose the features. And basically what I do is you use the simulated position and speed to predict the real position, but it is the one of the position. So after doing this, we can get the results. So you can see the actual values and the predict values, and there is a small difference. And to see more clear, you can see there is no big difference, right? So it means we have the good performance on this datasets, which use the linear regression. And second, we use the random forest to see if we can get the same performance. And you can see that from the results, and there is a huge difference between the actual values and the predict values. So it means the linear regression is better than the random forest. So the next task is about the cluster. And first, also I just import the dataset, and the first part of the cluster is to k-means cluster is to determine the k values. So I use the elbow method and another kind of method to calculate the score to choose the best optimal k value. But you can see from the elbow method, we cannot choose the good k, because there is no big there is no big features to like the shape of the elbow, but we can choose the best of k values from the score map. So we choose the 6 as the k-means value. So you can see from the output, and basically we can we almost get a good cluster in this dataset. So the second dataset is related to the market transactions. So also I import them from the HDFS, and you can see there is a product ID, order ID, user ID, or order number, order hour of day, and reordered. And then we want to see the data visualization. So this is the number of orders of each day of the week, and this is number of orders each day, each hour of the day. And also we can see the top 10 most ordered products and the numbers of reorder or not reorders. And also we check missing values, and we check the missing values, and we fill them with the 0 values. Also we check the outliers, use the box plots. So the next task is about the classification task. So we also choose the needed features and use the machine learning library to do the classification task, and we will use random forest. And also before determine the final model, we use the gray search to find the best hyperparameters, and use cross validation to choose the best model. So you can see from the results, the test accuracy is based on the optimal model. So you can see the different results with the different combinations of hyperparameters. So you can see this is a evaluation. This is different combinations of parameters, and this is the performance. So this is the confusion matrix of this of this results. This is the ROC curve. So the next task is the association rule, and from firstly we want to see the shape of the dataset. So we import the order products and the products, and we also show the some data of the dataset. So you can see there is order ID, reorder, and the product name. So before we do the association rule mapping, and we just join the two tables and together with the one tables, and then we do to find the frequent item set and to show the association rule. You can see the item set of the frequency, and you can see the confidence and the left value for each transaction set. So from this part, we can set the top 10 frequent item set, which is bananas and a bag of organic bananas, or some other products. And this is top 10 association rule by confidence. So this is the first product, and this is the entire association rules by confidence, and you can see the top 10. So that's all my individual project. So this is my demonstration of my individual project.